Hello and welcome to a lecture on ice creams. No one knows exactly when ice cream was first produced. Ancient manuscripts tell us that the Chinese liked a frozen product made by mixing fruit juices with snow, what we now call water ice. This technique later spread to ancient Greece and Rome, where the wealthy in particular were partial to frozen desserts. After disappearing for several centuries, ice cream in various forms reappeared in Italy in the Middle Ages, most probably as a result of Marco Polo returning to Italy in 1295 after some 17 years in China, where he had acquired a liking for a frozen dessert based on milk. From Italy, ice cream spread through Europe during the 17th century, long remaining a luxury product for the royal courts. Industrial ice cream production began at the end of the 19th century when the first mechanical refrigerators were pioneered. Ice cream, a milk-based product, is a major product of the dairy industry and has become a dominant consumer product for large segments of the population. Ice cream is sold both in a packaged form and in open containers at retail outlets or ice cream parlors, which is distributed manually in scoops, cones, or sundaes. According to US standards, ice cream must contain at least 10% milk fat before the addition of bulky ingredients and must weigh a minimum of 4.5 pounds to the gallon that is soft frozen just before serving on the premises, so the formulas differ from hard frozen products. The fat content of the soft serve mixes is in the range of 4 to 12% and the serum solids vary inversely from 11 to 14% with fat content. Ice cream and related products are members of the frozen dairy desserts family and are defined in the Code of Federal Regulations, Title 21, Part 135. These frozen desserts are defined like this. Ice cream is basically defined as that food produced as a result of freezing while stirring a pasteurized mix followed by homogenized and freezing. Ice cream can be divided into a number of categories. As legislation varies from one country to another, the following should be regarded as a guideline only. The fat content of ice cream typically determines the category to which it belongs. In some countries, fat content has to exceed 9% to qualify for the ice cream category. Below this level, the product is typically called milk ice, whereas ice cream with more than 12 to 13% fat is often categorized as either luxury or premium. The fat can be either of animal or vegetable origin. If the latter, legislation in a number of countries dictates that the product cannot then be called ice cream, but must be labeled, for example, non-dairy ice cream. In Denmark, the special term ermol has to be used. Some of the types of ice creams are reduced fat ice cream. It contains at least 25% less total fat than the referenced product. Light ice cream. It contains at least 50% less total fat or 33% fewer calories than the referenced product. Low fat ice cream. It contains a maximum of 3 grams of total fat per serving. Non-fat ice cream. It contains less than 0.5 gram of total fat serving. Now, let us move over to the composition of ice cream. An ice cream contains milk fat 10% to 16% or greater than 10% by legal definition and usually between 10% and as high as 16% fat in some premium ice cream. Milk solid not fat 9% to 12%, also known as serum solids, contains the proteins caseins, whey protein, and carbohydrates found in milk. The SNF contains on average dry weight basis 38% proteins, 54% lactose, and 8% ash, including calcium 1.38%, phosphorus 1.07%, potassium 1.22%, and sodium 0.7%. Sweeteners 10% to 14%. It is usually a combination of sucrose and glucose-based corn syrup sweeteners. Emulsifiers and stabilizers 0.5% to 0.25%. and water 55% to 64%. Let us now go through each of these ingredients in detail. Fat. Fat makes up about 10 to 15% of an ice cream mix and may be milk or vegetable fat. Milk fat or fat in general, including that from non-dairy sources, is important to ice cream because of these reasons. Number 1, it increases the richness of flavor in ice cream. Number 2, produces a characteristic smooth texture by lubricating. Number 3, helps to give body due to its role in fat destabilization. Number 4, aids in good melting properties due to its role in fat destabilization. Number 5, aids in lubricating the freezer barrel during manufacturing. Milk fat is used in the form of whole milk, cream, butter, or anhydrous milk fat. Sometimes, the milk fat is replaced by vegetable fat, hydrogenated coconut oil, and palm kernel oil. The blends of oils are often used in ice cream manufacture. Selection takes into account physical characteristics, flavor, availability, stability during storage, and cost. The use of vegetable fat in ice cream is regulated by legislation in many countries. During freezing of ice cream, the fat emulsion which exists in the mix will partially destabilize or churn as a result of the air incorporation. Ice crystallization and high shear forces of the blades. This partial churning is necessary to set up the structure and texture in ice cream, which is very similar to the structures in whipped cream. Emulsifiers are used to promote this destabilization process. Duplicating this structure with other sources of fat is difficult. In various parts of the world, vegetable fat are used extensively as fat sources in ice cream. While selection of the fat, following factors should be kept into consideration. Number 1, crystal structure of the fat. Number 2, the rate at which the fat crystallizes during dynamic temperature conditions. Number 3, the temperature-dependent melting profile of the fat. Number 4, the content of high-melting triglycerides which can produce a waxy, greasy mouth feel. Number 5, flavor and purity of the oil. There are some limitations of the excessive use of butterfat, and they are: Number 1, cost. Number 2, hindered whipping ability. Number 3, decreased consumption due to excessive richness. Number 4, high caloric value. Now, solid not fat. Solid not fat consists of proteins, lactose and mineral salts derived from whole milk, skim milk, condensed milk, milk powders or whey powder. In addition to its high nutritional value, SNF helps to stabilize the structure of ice cream due to its water binding and emulsifying effect. The same effect also has a positive influence on air distribution in the ice cream during the freezing process, leading to improved body and creaminess. The quantity of MSNF should always be in proportion to the water content. The optimal level is 17 parts MSNF to 100 parts water. SNF ingredients have following beneficial reasons. Number 1, improves the texture of ice cream due to the protein functionality. Number 2, helps to give body and chew resistance to the finished product. Number 3, capable of allowing a higher overrun without the characteristic snowy or flaky textures associated with high overrun due also to the protein functionality. Number 4, may be a cheap source of total solids, especially whey protein. The limitations on their use includes off flavors which may arise from some of the products and an excess of lactose which can lead to the defect of sandiness prevalent when the lactose crystallizes out of solution. Excessive concentration of lactose in the serum phase may also lower the freezing point of the finished product to an unacceptable level. The best sources of the serum solids include sweetened condensed whole or skimmed milk, frozen condensed skimmed milk, buttermilk powder or condensed buttermilk, condensed whole milk or dried or condensed whey. Superheated condensed skimmed milk with high viscosity is sometimes used as stabilizing agent. Further, The proteins, which make up approximately 4% of the mix, contribute much to the development of structure in ice cream are emulsification properties in the mix. Whipping properties in the ice cream, water holding capacity, leading to enhanced viscosity and reduced iciness. The lactose crystallization due to a decrease in temperature favors slow crystallization insofar as it increases the viscosity, reduces the kinetic energy of the particles, and decreases the rate of transformation from beta to alpha lactose. Supersaturated state can exist. However, due to extreme viscosity, and it is likely that much of the lactose in ice cream is non-crystalline, stabilizers help to hold lactose in supersaturated state due to viscosity enhancement. Fruits, nuts, candy add crystal centers and may enhance lactose crystallization. Nuts pull out moisture from ice cream immediately surrounding the nut, thus concentrating the mix. Number 3. Sweeteners. Sugar is added to increase the solids content of the ice cream and give it the level of sweetness consumers prefer. Ice cream mix normally contains between 12 to 20% sugar. Many factors influence the sweetening effect and product quality, and many different types of sugar can be used, such as cane and beet sugar, glucose, dextrose, and invert sugar. The consistency of the ice cream can also be adjusted by selecting different types of sugar. In the production of sugar-free ice cream, sweeteners are used to replace sugar. Aspartame, sorbitol, and glycerol or mannitol are the most commonly used sweeteners and are applied in conjunction with the bulking agents such as maltodextrin. Sweeteners improve the texture and palatability of the ice cream, enhance flavors, and are usually the cheapest sources of total solids. In addition, the sugars, including the lactose from the milk components, contribute to a depressed freezing point so that the ice cream has some unfrozen water associated with it at very low temperatures, typical of their serving temperatures, that is, -15 to -18 degrees Celsius. Without this unfrozen water, the ice cream would be too hard to scoop. Sucrose is the main sweetener used because it imparts excellent flavor. It has become common in the industry to substitute all or a portion of the sucrose content with sweeteners derived from corn sugar. This sweetener is reported to contribute a firmer and chewier body to the ice cream, is an economical source of solids, and improves the shelf life of the finished product. Number 4. Emulsifiers and stabilizers. Emulsifiers and stabilizers are typically used as combined products at dosages of 0 or 5% in the ice cream mix. Traditionally, these products were produced by dry blending, but nowadays, integrated products are preferred due to their high performance and improved storage stability. Emulsifiers are substances that assist emulsification by reducing the surface tension of liquid products. They also help stabilize the emulsion during the homogenization process by creating smaller, more uniform fat globules. The emulsifiers are a group of compounds in ice cream that aid in developing the appropriate fat structure and air distribution necessary for the smooth eating and good meltdown characteristics desired in ice cream. Since each molecule of an emulsifier contains a hydrophilic portion and a hydrophobic portion, they reside at the interface between fat and water. As a result, they act to reduce the interfacial tension or the force which exists between the two phases of the emulsion. This causes a desorption of protein from the fat droplet surface, which promotes a destabilization of the fat emulsion, leading to a smooth, dry product with good meltdown properties. The original ice cream emulsifier was egg yolk, which was used in most of the original recipes. Today, two emulsifiers predominate most ice cream formulations. Number 1, mono and diglycerides. They are derived from the partial hydrolysis of fats or oils of animal or vegetable origin. Number 2, Polysorbate 80. A sorbitan ester consisting of a glucose alcohol molecule bound to a fatty acid, oleic acid, with oxyethylene groups added for further water solubility. Other possible sources of emulsifiers include buttermilk and glycerol esters. All of these compounds are either fats or carbohydrates, important components in most of the foods. A stabilizer is a substance that has the ability to bind water when dispersed in a liquid phase. This is called hydration and means the stabilizer forms a matrix that prevents the water molecules from moving freely. Generally speaking, there are two types: protein in the form of gelatin and carbohydrates including seaweed colloids, hemicellulose, and modified cellulose compounds. Stabilizers are used in ice cream production to increase the viscosity of the mix and create body and texture. They also control the growth of ice crystals and improve melting resistance. The functions of stabilizers in ice creams are: number 1, in the mix, to stabilize the emulsion to prevent creaming of fat, and in the case of carrageenan, to prevent serum separation due to incompatibility of the other polysaccharides with milk proteins, also to aid in suspension of liquid flavors. Number 2, the ice cream at draw from the scrapped surface freezer to stabilize the air bubbles and to hold the flavorings, for example ripple sauces, in dispersion. Number 3, in the ice cream during storage to prevent lactose crystal growth and retard or reduce ice crystal growth during storage, also to prevent shrinkage from collapse of the air bubbles and to prevent moisture migration into the package. Number 4, in the ice cream at the time of consumption, to provide some body and mouthfeel without being gummy and to promote good flavor release. Limitations of the stabilizers include production of undesirable melting characteristics due to too high viscosity, excessive mix viscosity prior to freezing, and contribution to a heavy or chewy body. The stabilizers in use today include Locust Bean Gum, soluble fiber of plant material derived from the endosperm of beans of exotic trees grown mostly in Africa. Locust bean gum is a synonym for carob bean gum, to the beans of which were used centuries ago for weighing precious metals. Guar gum, from the endosperm of the bean of the guar bush, a member of the legume family grown in India for centuries and now grown to a limited extent in Texas. Carboxymethyl cellulose, derived from the bulky components or pulp cellulose of plant material and chemically derivated to make it water soluble. Xanthan gum. This gum produced in culture broth media by the microorganism Xanthaomonas campestris is an exopolysaccharide used to a lesser extent. Sodium alginate. It is an extract of seaweed, brown kelp, also used to a lesser extent. Carrageenan. Carrageenan, an extract of Irish moss or other red algae originally harvested from the coast of Ireland, the village of Carrageen, but now most frequently obtained from Chile and Philippines. Each of the stabilizers has its own characteristics, and often two or more of these stabilizers are used in combination to lend synergistic properties to each other and improve their overall effectiveness. Guar, for example, is more soluble than locust bean gum at cold temperatures. Thus, it finds more application in HTST pasteurization systems. Carrageenan is not used by itself, but rather it is used as a secondary colloid to prevent the weighing off of mix, which is usually promoted by one of the other stabilizers. Gelatin, a protein of animal origin, was used almost exclusively in the ice cream industry as a stabilizer, but has gradually been replaced with polysaccharides of plant origin due to their increased effectiveness and reduced cost. Number 5. Colors. Natural or artificial colors are added to the mix to give the ice cream an attractive appearance. Local legislation exists in most countries regarding the use of colors in food. Number 6. Other ingredients. Many molded and extruded ice cream products are coated with chocolate. Generally speaking, two types of chocolate coatings are used: real chocolate and chocolate compound, the latter containing cocoa powder instead of cocoa mass and cocoa butter, and vegetable fats such as coconut or palm kernel oil. Ripples are incorporated in ice cream for taste and appearance. They can be applied for pencil filling and top decoration. Dry ingredients are added through an ingredient feeder. A great variety of products are used: chocolate, nuts, dried fruit pieces, candies, cookies, Smarties, caramel pieces, etc. After going through the ingredients, let us try to understand the structure of ice cream. Ice cream is both fascinating and confusing. The texture of the ice cream when we consume it is based on its structure, and thus the structure is probably one of its most important attributes. Number 1, colloidal aspect of ice cream structure. Number 2, ice cream meltdown. And number 3, structure from ice cream. Now, let us go through each of them in detail. Number 1, colloidal aspect of ice cream structure. Ice cream is both an emulsion and a foam. The milk fat exists in tiny globules that have been formed by the homogenizer. There are many proteins that act as emulsifiers and give the fat emulsion its needed stability. The emulsifiers are added to ice cream to actually reduce the stability of this fat emulsion by replacing proteins on the fat surface, leading to a thinner membrane more prone to coalescence during whipping. When the mix is subjected to the whipping action of the barrel freezer, the fat emulsion begins to partially break down and the fat globules begin to flocculate or destabilize. The air bubbles which are being beaten into the mix are stabilized by this partially coalesced fat. If emulsifiers are not added, the fat globules would have so much ability to resist this coalescing due to the proteins being adsorbed to the fat globule that the air bubbles would not be properly stabilized and the ice cream would not have the same smooth texture. Number 2, ice cream meltdown. One of the most important manifestations of ice cream structure is its meltdown. When you put ice cream in an ambient environment to melt, two events occur: the melting of the ice and the collapse of the fat stabilized foam structure. The melting of the ice is controlled by the outside temperature and the rate of heat transfer. However, the ice cream does not melt until the fat stabilized foam structure collapses, and that is a function of the extent of fat destabilization, partial coalescence, which is controlled mostly by the emulsifier concentration. Number 3, structure from the ice crystals. Adding structure to the ice cream is the formation of the ice crystals. Water freezes out of a solution in its pure form as ice. In a sugar solution such as ice cream, the initial freezing point of the solution is lower than 0 degrees Celsius due to these dissolved sugars. This is mostly a function of sugar content of the mix. As the ice crystallization begins and water freezes out in its pure form, the concentration of the remaining solution of sugar is increased due to water removal, and consequently the freezing point is lowered. This process of freeze concentration continues to a very low temperature. So, this was all about ice cream. I hope you enjoyed the lecture. Thanks for watching.